All right. So today, what we're going to do is we're going to graph equations, but from real world problems. So what we're going to have to do is we're going to have to create equations and then graph them on a um, on a coordinate plane. And as we learned yesterday, we know that real world problems only live in quadrant one. So we're going to be working on that today. So there are two things I want to go over today, two definitions. The first is an independent variable. All right. Independent variables are X values. All right. X values. So that means any value that is on the X axis is independent, means that it could be whatever it wants to be. It chooses what it's going to end up being. Dependent variables are Y values, all right, which are on the Y axis. All right. Y values don't get to choose what they want to be. They are whatever the X value tells them to be. So, all right. The big thing today is understanding what X and Y values are, X being independent, Y values being dependent. And we're going to get started. So here we go. Example one. So we're going to go and we're going to combine a couple lessons here. We're going to combine writing equations, which we did last unit, and then graphing them, all right, which is going to be new today. So here we go. Number one, it says a taxi company in Kansas City charges $2.50 per ride. So that means to get into the car, it's $2.50 plus $2 for every mile driven. Now, every mile driven, we don't know how many miles. So odds are miles are going to be our X value. All right. Now it says write and graph an equation that models a scenario. So check this out. All right. Our known quantities are this. First off, we know it's $2.50 for a ride. So that means to get in there. All right. It's also $2 per mile. All right. So every mile we drive, you're paying $2. Now, here's the deal. What we don't know is X, miles. All right. I don't know how many miles. Miles, we can go anywhere we want in the city and we can choose how many miles we want to go. What we don't get to choose is our Y value, our dependent variable. And the Y value in this problem is the money. All right. So money, how much money we have to spend to go in this car, to go in this cab. So the equation that we're going to write is a linear equation. Again, it's linear because we don't hear doubles, triples, half. There's no percents. All right. All it is just linear. So it's Y equals. So our money, our total money equals. Now, this can be written a couple ways. So think about it. You're going to pay $2.50 plus every mile we drive, which is 2x. So it's $2.50 plus $2 for every mile you drive. And you don't need dollar signs, but sometimes it helps to make sense. So this is our equation. Now, here's the deal. For this problem, what I did is I actually gave the values of this problem in a table. Now that's how we're going to start graphing. We're going to use tables. Eventually we'll use our graphing calculator, all right? But what I did is I have my X, my miles, all right, and my Y is my money. And what I did is I just typed in my calculator. I would put 0 in and I go, all right, here we go, 250 plus 2 times 0. And that's how I popped out $2.50. And then I do it again. All right, let's try 1 now. All right. I went 250 plus 2 times 1 in my graphing calculator. And then I got ding, 450. And I kept going all the way down to 10. Now, this 10 is going to be important because here's the deal, right? Because miles get to choose whatever we want. I chose how far I went to. I chose to stop at 10. Now, could I have shown 100? Of course, but I don't want to type in 100 numbers. All I really wanted to do was see, all right, well, how much would the cost be for every mile up to 10? All right. Now, here's the deal. What we're going to do is we're going to graph the scenario on this graph. So here's the deal. Ready? I'm going to make my screen a little bit smaller so you can see everything. Whoa, that's really big. Hold on. There we go. Much better. All right. So now, after we identify all these values, the first thing we're going to want to do when we're graphing a real world problem is we're going to want to label and scale our X and Y axis. Now, label and scale are what we call them. So X is our miles. All right. When we label, we always want to give some space because we're going to end up scaling here. And then our Y is our money, how much it costs to ride in this cab. All right. Then we need to scale our X and Y. Now, Here's the deal. We always start, put a little star here, start with X. And some people are like, why do you start with X? Well, X's are easy, all right? X's are really easy. What I'm going to do is I'm going to realize, all right, my miles that I chose were 0, 1, 2, 3, 4, 5, 6, 7, all the way to 10. So what I'm going to do is I'm going to list my miles out here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like yesterday, right? You need to label your X and Y values. So for me, I made my X values go by ones. I could have had them go by twos, three, fours, but since these only go by ones and they go up to 10, I just had them go up to 10. Now, my Y's are extra. My Y's, notice my Y's all go up by the same amount. Notice they're going up by twos, but they're kind of odd numbers. So what we have to do when we scale our Y's is we have to look at our largest Y value we have, which is 222.5. And what we need to do is we need to make sure that our graph goes up to at least 22.5. So what I'm going to do is I'm going to do this. I know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes on here. Now, we could do one of two things. We could go by threes. That would get us to 30. Or what I'm going to do is I'm going to do this. Check this out. I'm going to go 1, 2, and I'm going to make this 5. 1, 2, make this another 5, so it becomes 10. 1, 2, this becomes 15. 1, 2, this becomes 20. 1, 2, this becomes 25. Now you might be like, why did I do that? Well, counting by fives is really easy, and I knew that I could go 5, 10, 15, 20, 25. Now, by doing this, by counting by fives, or, all right, some people might have done this, 10, 20, 30, 40, 50, that works too. All right, so however you feel like you want to count. But notice I give some space here, all right? I want to give some space and give some size. I'm going to go back to making this go by fives, all right? I'm going to go by fives because I think this is interesting and I think it hits home a point here. So one thing we have to do before we start graphing is we just have to know what each box equals. Since I made every other box go by 10, or 5, excuse me, each little box goes by 2.5, 2.5, add another 2.5, 5, add another 2.5, that's 7.5, and so on. So each box is 2.5, and that's going to be very important when we graph this. Now, all right, for this one and only time when we graph, all right, I'm going to ask for a couple things, all right? Before we can identify the x-intercept and y-intercept, this is what we do after we graph, all right? What we're going to do is we're going to take all of these coordinates and we're going to put them on here. Now, this is the only time I'm going to show you that we're going to graph them one at a time, and this just takes forever. So what I'm going to do is I'm going to start at 0, and I'm going to go 2.5, 0, 2.5, and I put a point. Now the next one's 1 and 4.5. Now I don't see 4.5, but I'm going to guesstimate 4.5 is about there. 2 is 6.5, so I go 2, up 6.5, and I go here. Now I'm going to keep going, all right? And we're going to notice that it should follow the same pattern, a linear pattern going this way, all right? Now what I would encourage you to do is pause the video, right? And you fill out the rest of these on here and see what I have. Otherwise, you can listen to this. All right, so 3 is 8.5, that's right about here. 4 is 10.5, just over 10. 5 is 12.5, which is right here. 6 is 14.5, which is right under 15. 7 is 16.5, which is right about here. 8 is 18.5, which is just about here. All right, just above that line. 9 is 20.5, so just above 20. And 10 is 22.5, which is ding, ding, ding right there. All right. Now, we plotted all of our points. So now we're going to connect our points with a line. Now, I'm going to do something that I'm going to start encouraging you to do. I'm actually going to use a straight edge. I'm going to use a ruler right now. I'm going to start at my y-intercept, and I'm going to go a straight edge all the way through here, and bam, there is my line. All right. Now, for us to see it, I'm going to make it a different color just so we can really kind of see this sucker. What color should I choose? Not purple. We'll use orange. And I'm going to make it a little thicker. All right. So there we go. Ready? So we got our line right there. Now, we can identify a couple things. Ready? Number one, all right, we're going to identify the x-intercept. So where does it cross the x-axis? Now, you might be saying it doesn't. You are correct. So we're going to say none. There is no x-intercept here. How about a y-intercept? And there is. The y-intercept is 0, 2.5, and bam, you just graphed a real world problem. All right. Now, so we understand a couple things. All right. This, as I said, is the first and last time that we're going to graph all these points. From now on, all right, after this problem, we are going to graph 2 points. And the 2 points we're always going to graph are these two, the first and the last point. All right. The first, which would be 0, 2.5, and then the last one. Since our last point was at 10, we're going to go up to 22.5, which would be here. And then notice we can create a straight edge between these 2 points, and it would go like this. And what it does by doing this, one, it's going to save us a ton of time. Two, it covers every point that we have on here. All right. And it gives you the best line possible. So from now on, we're going to do the first point and the last point, and that's how we're going to do this. Okay. So that is what we're doing today. Writing equations, filling out tables, and then graphing them. All right. So we're going to get some practice now. Flip the page. Oop, we're going to flip it. Now it says warm up here. This was from last year. Hold on. Let me delete this. Not the page. Hold on. Let me delete this thing. All right. You know what? I'm going to shrink it. It's not a warm up. We're doing this together. Ready? Now, example 2. Now you might be like, I swear this looks familiar. You're right. You've seen this problem before. It was in the last unit. And you're going to be like, wow, this seems very similar to the last problem. You're right. I'm not that creative, right? So I want to make sure we understand how to do these types of problems. It says a cab company charges an initial rate of $4.50 per ride. All right. So each time you get in the car, you're going to pay $4.50. Now, in order for the car to drive, you're going to pay 50 cents for each mile. That is what's going to change. When we get into a cab, you choose what your miles are going to be. So X is going to be miles. That's going to be our independent value. What we don't get to choose is it says, what is the equation that models the total fee? This is your Y value. It's your fee, how much you're going to pay. So our fee. All right. So now what we're going to do is we're going to notice known quantities. You could write them out. I like just underlining them. All right. You don't really need to write those out. I'm going to write our equation out here. So here's our linear equation. So our linear equation is going to be our total fee. So our money equals. Now, what are we going to pay to ride in this cab? Well, we're going to pay $4.50 to get in the cab plus, because it says plus, we're going to pay 50 cents. So 0.50x. So we're paying 50 cents for every mile that we go in this cab. All right. Now, what we're going to do is we're going to use this linear equation to fill out this table. Now, remember, the X is miles and the Y is money. Now, with this being the first time we get to choose this, what I would encourage you to do is this. All right. Make your life easy and try to do things almost always the same. All right. The equations are going to change, but this should always be the same. Here's the deal. Ready? If I'm going on a trip and I'm driving somewhere in a cab, I'm probably not going more than 10 miles. So what I'm going to do is I'm going to start at mile 0 and I'm going to fill out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 10 miles. Now, what I'm going to do is I'm going to take my equation here and I'm going to substitute in these X values into every X that's here. So let me show you what it's going to look like. We're going to get 450 plus 0.50 times 0, right? And you're just going to substitute it in. So 450 plus 50 times 0 is 0. So we're going to be left with $4.50. So if you go no miles, you're paying $4.50. So we're going to keep doing it. Now, ready? We're going to go 1 mile. All right. How much are we going to pay? Well, here's the deal. Ready? 450 plus 50 cents times 1. Well, in our calculator, if you put this in with parentheses, you're going to end up getting 5. It's $5. It's 50 cents more. And then we keep going. 2. All right. So now we go 2 and we're like, all right, here we go. 450 plus 50 cents times 2. And you type that all in and you're going to end up getting 550. And you notice, oh, there's a pattern. This is increasing by 50 cents. So we're just going to, instead of typing this all in our calculator, the pattern is add 50 every time. So we're going to go 6, 650, 7, 750, 8, 850, 9, 950. So for 10 miles, you're going to pay $9.50. And I really should put zeros there. All right. So $9.50. Wonderful. Now, before we graph, all right, before we graph, we need to make sure we do these two things: label X and Y and scale X and Y. So the labeling should be easy, all right? Because if you address the independent and dependent variables, or you write them here, you're literally going to write them down here. So we got miles is our X, all right? And then money is our Y. Now, if you look at our graph, this graph goes back to the type of graph we had the last lesson. It's our 20 by 20 graph. I believe it's 20 by 20. Was it 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. Good. All right. So it's our 20 by 20. So here's the deal. Since we have 20 boxes on here, we could go 0, 1, 2, 3. We could do that. But notice our numbers are really squished together. What I like to do is I like to make some space here. I like to make this graph almost fill out the entire thing. Do you have to? No, but I do. So this is what I told you before, all right? You choose your X, all right? You chose our X's. So our X's go up to 10. So I'm going to fill this out, and I'm going to space it going every box is 1 mile. So 0, 1, skip 2, 2, skip 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? Now, our Y's, we didn't get to choose, but we have to make sure that our graph goes up to 950. Well, if you think about it, there's 20 boxes. There's plenty of room to go up to 950. Now, you could do one of two things. You could do the same scale like I did to go up to 10, and that's what I'm going to do. Or, you could be a little more creative and maybe you go by 50 cents. I don't know. But this is what I'm going to do. Ready? I'm going to make this 1. Every other box 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And really, each box, and I said it's important to know what each box going up is actually 0.5 or 50 cents. You see that? So it's actually really cool. This is actually a great scale for this problem because it matches perfectly. Now, we are doing big boy, big girl math here. All right? Big boy, big girl math means that we are only going to graph this problem using 2 points. The first point and the last point. That's it. 2 points, and then you use a straight edge. So ready? We're going to start with our first point here. Our first point is 0, 450. So 0, go up 450. There's our first point. Ooh, that's kind of nasty. I'm going to erase that a little bit. 450 is right here between 4 and 5, and really it's 450. Then we graph our second point. Because this is a linear graph, because we're just adding 50 every time, it's linear, all you need are 2 points on here. The first point and then our last point. The last point we have on our scale, which is 10. And our 10 we know is 950. So we're going to go up to 9. So I'm looking across here, 9, but we want 950. And boom, there you go. So we have our first point and our last point. Now you might be saying, that's not a line. You're correct, because we need to put a line here. So we're going to put a line, a straight edge. So you're going to start your straight edge. Make sure you take your ID card, a ruler, your cell phone. All right. And you line it up from this dot to this dot. And here we go. Boom. We make a straight line, and make sure that your line, you're putting arrows at the end of it. All right. It's very important. You're putting arrows. Come on now. Where's my stuff here? Why isn't this? Oh, clearly doesn't like me. All right. I would make this bigger. But anyway, all right. Make sure you got your arrow on there and you're golden, because it only goes up and to the right. So there you go. You labeled, you scaled, and you made your graph. And this to me is way easier because it literally encompasses all your points. If you're like, no, Mr. Qualman, I don't believe you. Like, this doesn't work. Well, let's just check a point. Let's try this one. How about 5, 7? Does 5, 7 land on our line? Well, let's look. All right, 5, and then we're going up. Just keep going up from 5. Look. It should hit here. And look where it goes to. 5. Holy smokes, it landed at 7. So if you do the first point, last point, it will encompass all your points on your graph. I promise. Okay? Now, let's answer a couple questions. Identify the x-intercept and y-intercept. So ready? What's our x-intercept? Now you're looking x-axis down here. Do you see an x-intercept? Does our line touch it? Nope. So we say none. Our y-intercept, though, is on the y-axis, and there is one, and this is 0, 4.5 or 450. Now, let's just quickly talk about what this y-intercept means, all right? Now, our y-intercept is 0,450, so it means 0 miles and $4.50. So that's your money. All y-intercepts are your starting point. So what I do is I always try to encompass this into like what the problem means. So it is our starting value to pay. That's really what it means. It's how much we're going to have to pay right away. You're paying $4.50 to sit down, and then as you choose your miles, then your price increases because that's what our line tells us. You see that? All right. So here we go. I have one more problem for us to do. All right. And this one is on the next page, which I am not sure. What is that? It's page 14, 15. It is page 16. All right. So ready? Page 16. So this is our last question, and then I'm going to have you do some homework problems, all right? So it says, you and some friends are hiking on Mount Rainier. That is a mountain. You started with 100 pounds of food. Pounds of food for your group. And you eat about 10 pounds each day. What is the equation that models the amount of food you have left? So here's the deal. Our question, all right, is our y values. So pounds of food left. That's our y value. How much do we have left? And x is what changes. So when you're on the mountain, the thing that you can choose is how many days you spend on the mountain. All right? You don't choose how much food. We already know you're eating 10 pounds of food. The thing is, you choose how many days you're going to end up spending on that mountain. Unfortunately, you have a finite amount of days. You don't get to stay there infinitely. You can only be on there for a short amount of time. And here's the reason why. All right, when we write our equation, we're going to write y equals, so pounds of food left equals. So here's the deal. We start with 200 pounds of food. Then we're going to eat, which means we're going to subtract 10 pounds every day, which is x. Because you're going to remove the pounds, 200 pounds. You're removing 10 pounds every single day. All right? Now, here's the fun part. Ready? Here's the fun part. This graph, all right, this graph is actually going downward. It's going to go downward because I want you to think about this. You're going to start with 200 pounds. And the longer your days go, all right, the longer your days go, your amount is going to actually decrease. So for this problem, what we're going to do is we're going to start with day 0, all right, day 0, and then we have pounds of food, pounds left. All right, now here's the deal. On day 0, you're going to start with 200 pounds. The thing is, for this graph, because we know it's going down, we want to know when it hits the x-axis. So when will it hit the x-axis? Well, when it's going to hit the x-axis is when our y value equals 0. All right? So here's the deal. For this problem, we aren't going to fill out all these tables. You can, all right, but we're not. We're going to fill out the first day and then our last day. All right? So first and our last day on the mountain. Because you have to leave the mountain when you have 0 pounds left. Otherwise, you are eating humans. That's not a good thing. All right. Or you got to go and start hunting. All right. So we are going to take our calculator, pick it up, and you're just going to go like this. You're going to go 200 minus 10, which is 190. And you keep going, minus 10, minus 10, minus 10, until you get to 0. Right. And what you want to do is you want to see how many days is it going to take us to get to 0 pounds of food. Ready? The answer is 20. You can stay on the mountain for 20 days, and that's when we're going to be done. All right? That's when you're going to be done. It takes 20 days to get to 0 pounds of food. So we need, for this problem, we need to know this last day, and we need the first day. Because that's how you graph, but you really, 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 you need to know this last day. Because we don't want to graph a line, start here, and have it like end like this. We don't want it to be like that. We want our line to start here and hit somewhere. We want to know where it touches. Anytime your line goes down, we want to know where it touches here. So that's why we needed to know when we got to 0 pounds of food. So here we go. Ready? So now let's label our X and Y axis. So we're going to label this thing. Here we go. So we got days, all right, and pounds of food. All right, now our days. Let's start with our days. We got to get to 20. So check this out. We have 20 boxes on here. So our last box is 20. So that means every day, 1, 2, 3, 4. I'm not going to put them all on there, but watch what I'm going to do. I'm going to go by twos. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. Now here's the cool thing. We know on day 20, we're going to have 0 pounds of food left. Now what we need to do is we need to make our Y value get up to at least 200. Well, if we got to go up to at least 200, here's the fun part. What I would do, because we are only going to graph these 2 points, and we already know our x-intercept is 0 or 20, 0 right here. Let's make this super easy. Watch this one. Ready? I'm going to make this line 100 pounds of food. So 1, 2, 3, 4, 5 made us 100. 1, 2, 3, 4, 5 gives us 200. 1, 2, 3, 4, 5 gives us 1, 2, 3, 4, 5 gives us 300. And 1, 2, 3, 4, 5 gives us 400. Now you might be saying, why does he go up to 400? That's weird. All right. It doesn't matter because we are going to start at 200 pounds of food in 0 days, and our line's going to decrease. It's going to go down. Now watch how I make this line now. Bam. There's my line. You see that? So for this, you do all the hard work at the beginning. You had to figure out the last day and the first day because you needed to graph this, and then your line goes like this, okay? Any other day on here, I don't care what it is, we'll be able to look at it from the graph, or we'll be able to use the equation, but I want to model this scenario so we know on the 20th day, you got to be off the mountain. So here's the deal. We label, ding, we scale, ding. What is our x-intercept? This is the first time. It's 20, 0, all right? And then lastly, identify the y-intercept at 0 to 100. Now, ready? I love these questions. What does the y-intercept tell you about the situation? It's our starting amount of food. It's what we start with, and that the starting is huge. The x-intercept tells us the number of days we can stay on the mountain. All right. Anything more than 20, we're in trouble. We have no more food. Now, what values of x do not make sense? Now, here's some values that don't make sense. Can we be on the mountain for negative days? Absolutely not. We all talked about this. Negatives really don't exist in real world problems. All right. Does like the day 30 make sense? And you're probably saying, yeah, you could, but here's the deal. Any day greater, so days greater than 20, those don't make sense, all right? Because those are days where we don't have food and now we're in trouble. And lastly, what y values don't make sense? Well, guess what? It's the same ones. Negative, because you can't have negative food. You just can't. 0 is the most. And then values, so pounds greater than 200. Because you can't get food. Maybe you can hunt, but this problem is all about you start with 200 and you're losing 10 pounds a day. So this is the numbers that don't make sense in this problem, okay? So here's the deal. You're going to get started on your homework, right, which is on page, let me look, 18. All right, so we got 18 and 19. Those are your homework problems for today, okay? So 18 and 19, it's a combination of review and stuff we've done today and the last day, okay? Good luck. Crush it. Make sure that you're checking your answers on Google Classroom.